So, hello everyone, welcome to WWS show. And today we are going to find the hypotenuse of a right angle triangle which has the same base and the same perpendicular, right? So, in this case, you can see the figure of a right angle triangle with lambda being the hypotenuse. And we want to find the value of lambda without using the Pythagoras theorem, right? So we define a function f which takes the base and perpendicular, in this case both are same, and spits out the hypotenuse which is lambda. So we'll start with this splitting. So we have divided this base and perpendicular into n parts. So this is the same triangle with the base A and perpendicular A. We have divided both base and perpendicular into n parts, right? So splitting this base will give you this triangle at the hypotenuse. So we'll pick one of these triangle. All of them are same. We'll pick one of it and we'll see that its base is a by n and perpendicular is also a by n with the hypotenuse lambda by n. Now if we repeat this process with this smaller triangle, this triangle here, and we'll further subdivide this triangle by splitting the base and perpendicular, we will get the another triangle, right? Now in this case, the base being a by n, perpendicular being a by n, this smaller triangle will have the base a by n square, right? And the perpendicular will be a by n square also, both are same, and similar for the hypotenuse. So as you go more and more deeper into smaller scale, you will see the lambda will be divided by n every time you scale down, and same for the other lengths, the and perpendicular and base. So we can say in general, if you do this procedure for k times, then you will have lambda by nk. Okay, this is the hypotenuse at that kth level. It will be the function of a n k and a n k, right? And also we know that the lambda is simply the function of the base and perpendicular. In this case both are same, and uh, we can substitute this value of lambda in this equation. We'll get this final equation we will label 1. So lambda will be n by k times the whatever the function gives you at these base and perpendiculars. Now we also notice this for a triangle like this, for a isosceles triangle with the same base and perpendicular, which is A. If you draw this line perpendicular to the hypotenuse, you'll see this height, this length is same as lambda by 2, and this is also lambda by 2, right? This in total it's lambda, and this is lambda by 2. This is also lambda by 2, and this is A. We already know it. So it will form this another right angle triangle with the same base and perpendicular. So we can write the function as the function will take this as base, this is perpendicular, and spit out the hypotenuse A. So for this triangle we write the equation 2. Now we'll substitute this lambda here in this equation 2. So we will have the value of A in the form of A, right? And we must realize that this equation here, if this function gives some sort of definite value, then when k will tend to infinity, this whole limit will tend to some infinity. So you won't have some finite value of a, which is not the case. So for the limit to exist, we must analyze these input this function, right? So this input to the functions is this, both are same, n raised to power k divided by 2 times the function a n k, right? So it should have a finite value when the k approaches infinity, and it is only possible if this nk outside the function, it cancel out this nk inside the function. Because if inside the function this 2 nk cancel out each other, then nothing will have to cancel out this nk outside the function, and because of that they cannot cancel out inside. And for that matter, we can think about it. So a function must be able to spit out this nk value out, keep whatever inside in the form of g. So which is only possible if f lets out the common factor of x and y in a function which takes input x and y. So uh, the common factors of these two inputs to the function will be able to let it out, right? Like in this case. So for example, you have a function of ma comma mb. The m is common in x and y, so it will be must be able to take out of the function. So we can write it as m times f of b. So if we consider that that's the case, and if that is the case, then we can take out the both a and k because it's common in both the inputs. So this whole function will turn out like this. The a and k will be multiplied with f of 1 and 1. So and now we have this equation of a, the our equation 1. If we apply this limit k tends to infinity, and now we want to estimate some value here, right? Now we know the property of function. We can take out the common value of the input parameters in both the cases, and this will turn out like this. And the nk which is taken out of function will be cancelled out by the nk outside it, right? In both the cases. So we're left with this thing, and limit will disappear as we will apply it because there is no k, so it will be same. So a will be a function of a by 2, and this multiplied f of 1 comma 1, similar for the second parameter. Now this outside function is the same as the function inside, right? So it will also do the same thing. So both are same, they will be taken out of the function. So it will turn out to a by 2 f of 1 comma 1 and into f of 1 comma 1, right? So since a is greater than 0, it will cancel out, and we will have the f of 1 comma 1 uh, which is squared of it equal to 2, right? So we'll have f of 1 comma 1 equal to root 2. Now what this says that if you have a writing a triangle, the base 1 perpendicular 1, the hypotenuse length will be root 2. And then you can find it for a general uh, base and perpendicular, given both are same, that is equal to a. So a was the f of lambda by 2 and lambda by 2, and we can take out lambda by 2 common, we left with this lambda by 2 into f of 1 comma 1. We know the value of 1 comma 1, which is root 2, and then if you solve for lambda, you will get root 2a. So if you have a triangle with the base a and perpendicular a, then you will have the hypotenuse, which is the base or the perpendicular times root 2. And that's how we can find that the if you don't have the knowledge of Pythagoras theorem, you can use this basic math, basic intuition, and basic logic to figure out the hypotenuse in a triangle where base and perpendicular are same. So that's it for the video. Thank you.